Polynomials are something you've been studying for quite some time now. And today we're going to look at the idea of zeros of polynomials and their solutions. This is the generic representation of a polynomial. You're used to seeing something a little more like this, but just to give you the general definition, this first value, which we'll refer to as a sub n, is what we call the leading coefficient. In our example here, the leading coefficient would be -3. And this n value is what we call the degree, or the highest exponent, when we write the polynomial in descending order. In this example here, the degree would be 5th degree. Notice this last term does not have a variable, and this is our constant term. In the example below, our constant term is 1, but you can also think of this as like x to the 0 power. And if you remember, anything to the 0 power is equal to 1. Make sure you know how to identify leading coefficients and degree. Both of those are going to come in handy in the next couple of sections. The second thing we want to look at is the idea of what we're going to call the zero of a polynomial. What we mean by that is if we set the polynomial itself equal to 0. So in our example above, if we had set -3x to the 5th plus 2x squared plus 1 equal to 0, I want to know what x's make this true. If we have a graph, and this is not the graph of that example, but if we have a graph, notice that when the polynomial equals 0, that means y is 0. So the x-intercepts are also the zeros of the equation. If you have a graph, they're easy to identify. Another way to identify them is if we can verify a solution. To verify a solution, if we have a polynomial such as the one listed here, we simply take the value listed and plug it in to see if it makes the equation true. Here, if we plug in 4, on the left side, we end up with 96 minus 64 equals 12 plus 20, which gives us 32 equals 32. It's true, so both sides are equal, and x equals 4 is the solution. Notice if we rewrite this and set it equal to 0, then we can also say that x equals 4 is a 0 of the polynomial. This is a good time for you to go back and review the ideas of complex numbers, because sometimes they may not be x-intercepts. They're only real solutions and cross the x-axis if they're real solutions, but we can have complex numbers or imaginary solutions. We follow the same steps algebraically. So we would plug in 1 plus 2i squared equals 2 times 1 plus 2i minus 5. You would need to FOIL this left side. And so you need to know the rules for multiplying complex numbers. On the right side, we would distribute. And when we simplify the right side, we combine like terms to get -3 plus 4i. We want to see if the left side equals that. When I do my first terms, I get 1. Outside terms, I get plus 4i. I'm sorry, plus 2i. Inside terms, I also get plus 2i. And then last terms, I get 4i squared. But hopefully you remember that I squared is simply equal to -1. So we end up with 1 plus 4i minus 4 equals -3 plus 4i. When we simplify the left side, we get -3 plus 4i equals -3 plus 4i. So this is a solution or a 0 of the equation, even though it is not a real number.